Hello again. I feel as though I really missed something important when I went through the last lesson, and it really is a way for you to check that the equation you've developed is correct for the graph. So I just want to take a few more minutes of your time, if that's okay, to go through this with you. So in example 1, we came up with this equation for the cosine wave. Now, if I want to verify that the equation is accurate, I can simply substitute some x values into the equation, determine their corresponding y values, and see if that ordered pair is on the graph. So let me show you what I mean here. So here's equation 1. Let me see, what does this even say here? I think 3.5 pi. So I know from the graph that when x is 3.5 pi, the height of the graph is at 1. So if I substitute that here, hopefully I will get y equals 1. So why don't we just try that together, okay? So we're going to use our calculators to help us. So for the first equation, let's say that we substitute x is 3.5 pi. So again, that corresponds to right here in the graph. It's what we indicated was our third critical point. So then what will we get? Well, we'll get negative cosine of 1/3. And this, of course, implies multiplication. So 1/3 times 3.5 pi minus pi over 6. So perhaps I can simplify this, all right? In fact, you could just put this into your calculator like this. We have to be in radians, not degrees. See the D here? I have to make sure I'm in radians. So for me, I do that like this. Pick 2. Now I'm in radians. Okay, so I used the mode button, but you'll have to check that's working for my Casio. Okay, so now I'm in radians. But as I said, I would like to work this out a little bit first. So what is 1/3 times 3.5? So 1/3 times 3.5 is, okay, I don't want to write down this mess. 1 1/6, or shift fraction button again, 7/6 pi. So this is the same as negative cosine of, so I can write 7 pi over 6 or 7/6 pi. So it's 7/6 pi minus, and this is 1/6 pi. Okay, so next thing I'm going to do is the subtraction. So 7/6 pi minus 1/6 pi is equal to 6/6 pi. Or in other words, 1 pi. So the whole inside of the bracket becomes pi. If you want to do that, you can have 7/6 on your calculator already. You can just subtract 1/6 from it to see that you'll get 1, right? But we must keep the pi in there, so it's 1 pi. And now I just can put this into my calculator, the negative cosine of pi. Negative cosine of pi equals, and we get 1. So what we've determined is that when x is 3.5 pi, y is 1, which is consistent with our graph. And you can pick another point as well. So shall I show you with one more here? Why don't I do this one here? So this actually says, what does that say? 0.5 pi. Yes, so let's try that one as well. So when x is 1/2 pi, then substituting that into the equation will look like this. So So it's 1/3 times x. So 1/3 times half a pi minus pi over 6, right? So we just substitute 0.5 pi there. And then 1/3 times 0.5 you could do here if you want. Okay, it's that mess, which is actually the fraction 1/6. So this is 1/6 times pi, or pi over 6, however you prefer to write it. So now look what we're getting for the angle. We're getting 0. So now we have negative cosine of 0. We can put that into our calculator. Negative cosine 0, and we get -1. So when x is half a pi, y is -1. X is half a pi, y is -1. So these check out with our graph. And maybe I'll show you the other one too. Why not? So here's the second graph. So that was for graph 1. Let's just try something for graph 2. And I would stick obviously with the critical points when substituting, because, you know, let's suppose you picked a different point, then you're kind of approximating the height in the graph. I mean, it does give you an indication also of whether it's correct, but easier to choose one of the x values that are a critical point. What about 0 here? If I substitute x is 0, I should get a height of 3. So in example 2, let's try that. If x is 0, then what happens? Y is 3 times the sine of, so it's 2.5 times 0 plus 0.5 pi, like that. So that's 3 times the sine of 0 plus half a pi. So the angle is half a pi. Pi over 2 would mean the same thing, right? And then I want to put this in the calculator, and hopefully the calculator will tell me that that answer is 3. Okay, so we can just try it out here. 3 sine 0.5 pi. I think we should put a bracket just to be safe. Okay, so inside the bracket I'll put 0.5 pi, like that. Close the bracket, push equals, and can you see that? It says 3, so that works. Shall I pick one more? Let's pick one more. Which one should we choose here? What's this? 0.4 pi? Yep, let's try that one. We're thinking when we substitute 0.4 pi, we'll get an answer of -3. So x is 0.4 pi, y is 3 times the sine of 2.5 multiplied by 0.4 pi plus 0.5 pi. Okay, and should I show you that you could just, even without simplifying it, punch it in like that? Maybe. Let's go up here a bit. Okay, just need brackets though. So 3 sine bracket 2.5 times 0.4 pi plus 0.5 pi, close the bracket, and when I push equals, I'm hoping it says -3, and it does, right? So even if you don't go ahead and simplify this, you just punch it in left to right using brackets where required, and you'll get the right answer. If you wanted to simplify it, you would do this. 3 sine, and then you'd say, what is 2.5 times 0.4? That's 1. So this is 1 pi plus half a pi. So how many pies is that? 1.5. It's a lot of pi. Okay, and then you could just punch that in. 3 sine of, in a bracket, 1.5 pi, which is the same as 3/2 pi, but anyway. And there it is, also -3. Okay, so again, I just wanted to add that to the lesson because I do feel it's important. All right, thanks. Take care, guys.